Hey guys, Scott Moyes here from Capro Systems in New Zealand. Today I'm going to go through milling and turning this particular part here out in Inventor HSM. I thought it was a great example of mill turn, and it's got a couple of little tricky bits to it when it comes to setting up the job. So you could put it in some soft jaws in the lathe possibly, but also you could just put it in a 4-jaw chuck and set up the centre on the axis of the main spindle. So how would we go about doing that? Right, so for a start, I've kind of assumed that we'd machine this out of some bar stock, some rectangular bar stock, rather than cylindrical stock. And the best way to do that and to set this up, I've found, is to model it. So I've set up a work plane, which is 1 mil off the front of the job. Just give me some material to remove, and then I've created a sketch which is 1 mil offset all the way around. Now I could obviously dimension it to the stock that we've got and then center it on the job, but I've chosen to do it this way. Then I've extruded that profile out enough to have something to hold on to in the chuck, and then some clearance for parting off, handing off to the sub spindle or into the part catcher to finish off this chamfer on the back side. But then I also need a way to define where the coordinate system is going to be, where 0, 0 is going to be. So I just placed a work axis down the center of this cylindrical face, and then created a work point which is intersecting between this axis and this work plane here. Okay. So getting into the cam, let's do the setup. So setup. First things first is I want to be doing turning or mill turn. Alright, I need to define what my z-axis is. So before I do this, I'm actually just going to go and define my stock. So I'm going to choose from solid, switch back to the model browser by clicking this cam drop down and choosing the second body here, which the visibility is turned off. I don't need to see the model itself, but now I can see that the stock, the yellow stock region has been confirmed, so I can now switch back to the cam browser and come back into the setup. Right, so where is my z-axis rotary? Well, it's around the center of that face there, and I want to flip the z-axis, and the origin I actually want to be to a selected point. This is where I get to select this work point that I've created. And now everything is aligned exactly how I'd want it set up in the lathe. I just want to confirm here that if I clear that out and make sure that it's not going to select both the stock body and the part body, and just select that one body. You don't get a confirmation in this user interface telling you how many bodies have been included in the model selection. Alright, so the XZ plane is cutting through the part here, and if we're spinning this part, this point here is actually a larger diameter than this one. And if I'm going to turn this face as part of turning this profile, then I need to use this spun profile option. So I'll turn that on, and it's going to generate the spun profile within this tolerance. So first thing I want to do is remove some stock. I've got all this excess stock on here. I don't want to do any interrupted cuts when I'm turning, so I can mill it all away using my X and Y axis, X and Y axis, and the Z axis of course on my mill turn lathe. So let's do some 3D adaptive clearing. First things first is to choose my tool, and I've got a whole bunch of tools here already set up for me to use, so I'm going to use tool number 13 here, just a 6mm bullnose tool. I'm going to let it remove all of the stock that it can see, but I don't want it to drop all the way down the side here, so I'm going to change my bottom height to selection and just pick that face there. Okay. Then coming onto the passes tab, I want to use flat area detection because I want it to adjust its Z step down so that it stays within 0.5 of axial stock to leave on these two faces here. And I've got a 6mm tool, so I can go, I'm just going to bump this up to the maximum step down to 12mm and leave everything else as default. So while that's generating, I can now jump in here and do some facing, and you can see now that this spun profile has appeared, so it's actually going to turn all the way up this face instead of trying to cut in across the top here. So that's perfect. It's exactly what we want. Just need to select my basic turning tool. If I just let that generate now and see what it gives me. Right, so the facing operation is kind of stuck up here at the moment. So I need to just override these radiuses, okay? I want my inner radius to be set to a radius of 0. And then my outer radius, I can set that to selection. Let's pick this face here. And my clearance offset, I want it to be based on my outer radius. Oops, outer radius. And yeah, 10 mils fine. So you know what, I'm just going to change this to selection a second. Pick this inside face. And we'll change it back to a radius. Yeah, there we go. So radius inner offset 0. So that's perfect. And now when we generate this, we can now see it's coming in and parting off the material and coming just past the center, so that it doesn't leave a nipple in the center here, so that when we come in and do the spot drilling, we've got a nice clean flat face to use. Alright, so what's next? Now we've faced it off, let's do some profiling and remove the rest of the material that's been left behind by the 3D adaptive clearing here. We'll just see what kind of material we've got to get rid of. So I think we left 0.5 mil everywhere, so we can see there's just a little bit here. There's nothing too aggressive, but we do want to make sure it's going to clean up all of this material all the way out here, so we have to do a couple of extra passes, which looks like it won't do a lot until it actually gets to this face. So just for the sake of simplicity here, we're just going to let it do a few haircuts. We could contain it some more, but I'm not going to. So I'm going to use the same tool. When it comes to confinement, I'm going to confine between this face here and this face. Okay. My radiuses, my inner radius, I'm going to set this to selection. I'm going to pick this particular face here, but I've got to take account of the radius on the tip. So I want to come down and go minus 1.8 mil, so it just comes down inside slightly further. Actually, I'm going to select this face here instead. And then my outer radius, I'm going to use selection as well, but I'm going to pick this face here. And I just want to make sure that I am able to get toolpaths generated right out to these faces. Okay. And again, just change the clearance plane to match the outer radius, plus 10 mils. All right. Now, on the passes tab here, I want to do some finishing passes, but I want to make my finishing step over a lot smaller. And yeah, I'm happy with the rest of those settings. So now I've got that toolpath generated. If I now do another simulation and just check where we're at, and I'll turn off show transparent, and we can see now it's just cleaned up this whole face for us quite nicely as part of the same cut. So we've got a nice consistent finish all the way along. Let's just check to see whether we've got any stock left on the side here. There's a little bit, so we actually need to bring the tool, let the tool come down a little bit further. So let's just edit that containment slightly, and we'll give it another, let's just change that back to my original selection here. There we go. Yep, so it's just coming off the corner for the final pass. So there we have it. So that's all the initial turning done. Now I want to start removing some of this material. So I want to get back to a finished face here, so that I can spot drill and profile the outside of the part. So I've still got the Z-axis pointing out off this face, so it's exactly like doing milling in a 3-axis. So let's do a 2D contour. And this time we're going to use a larger diameter tool. We'll go with the 16 mil. I could just pocket this, or there's various other different techniques that I could use, but I actually just want to do 2 passes, right? So if I go and select my contour, I can also define a stock contour and choose this profile here and say, right, the only stock I want to remove is within that orange profile. That allows me to then come into the passes tab and turn on multiple finishing passes, and we could bump this up to if we don't know exactly how many step overs we can do. We've got an 8mm tool, so let's go 7mm. I don't know how big that face is, but I can just jack this up to whatever number I want and let it do its thing. And it's going to automatically figure out the 7mm step over. I need to do 3 passes to clean up that face entirely based on that stock contour. So good to go on that. Now let's do another 2D contour to clean up the bottom face. Switch to the geometry tab, and we want to select this clean external profile all the way around the outside. Now it's not quite deep enough to machine all the way past, and we're going to machine this chamfer once in the secondary operation, maybe on a different machine or in the sub spindle. So I actually need to get the tool to come further past the selection that I've made. So on the heights tab, change the bottom height from selected contour to model bottom. Okay. So if the model height changes, then this will adapt and change to suit. I could use selection as well if I want to, but I also want to go 1mm past that. I'm happy with everything else. I'm not leaving any material on, so that's all good. Let's check the toolpath. We've now got that shape cut out around the outside. If we want to get rid of any witness marks on here, we can actually come back in here and edit that, and then on the passes tab, turn on finishing overlap. We'll just add a value, so we can go 3mm finishing overlap, and now when we look, we can see that it's moving past the start point, just to remove any witness marks. So let's have a quick look at what we've got here now. So we'll play that, do it real quick. Yep, so it's starting to look more like the part. Now doing this profile around the outside has added these chamfers on, which is ideal. Alright, so let's do some spot drilling. To do that, we use the drilling operation, and we'll select our spot drill. Now I've got 2 spot drills set up. One's tool number 70, position 70, the other one's 71. So I can do the axial spot drilling with this tool, and then the radial spot drilling with tool number 71. So here, actually, I can do both in the same hit. So we'll go to geometry and select both that conical face, which automatically sets the depth, and then also this conical face. So we've done both in one hit. You can turn on some peck drill it, use a chip breaking cycle just to peck into it so it's not one big heavy cut, and leave it at that. Now while we've still got that tool selected, we can actually machine these chamfers onto the part. So let's do that right now. We'll use a 2D contour. We can actually use a spot drill for contouring. The system allows us to do that. And we want to select an open contour. So we click it once, click it twice, and choose the open contour option, and then come around and pick the final edge to cut, and it automatically finds the rest of the profile for us. Apply that, and by default, so now we've got the chamfer here, so I want to do a tip offset of 4mm, which is going to slide the tool down this chamfer face, so we're using the larger diameter of the tool to cut the chamfer, but also to avoid this tapered thread. Then on the linking tab, I want to set this to 0 degrees so that we come in straight off at the start and straight out at the end. Let's see what that gives us. Yep, that looks pretty good. Let's just check for clearances. So we go to simulate, we'll turn off the stock, turn on the toolpath, and just pick this start point here and have a look straight down the barrel. And we can see that the tool's going to clear that. Ideal. We could actually sit it down a little bit further if we wanted to increase this clearance, but I'm happy with that. Okay, so now we've got that one done. We actually want to use exactly the same parameters to machine this one. So let's duplicate it. Then right click and edit that. Come into the contour or into the geometry tab and clear that selection out. And this time, instead of selecting it and then clicking it again to activate an open contour, you can actually hold down the Alt key and make a selection that way, so it just picks a single edge. Let's increase the lead out distance slightly to go with 2.5 mils, so that the tool comes in and out, and just gets this extra little bit of the model to make up for the fact that this edge selection is slightly shorter. So that's both all of the chamfering done from on this side of the part now. So let's do some more spot drilling. This time we're going to spot drill on the end of this part here. So we're going to start doing some positional milling. So drill again. This time we're going to use number 71 because it's a radial spot drill. Geometry tab again, and this time we're going to select the conical face, and I can't select the conical face because it's outside of the selection range. So before I do that, I have to turn on tool orientation and define which direction the z-axis is going to be for this operation. So I can select a face, or I can select a cylindrical face. I'm going to select the cylindrical face, and the z's pointing away from us, so we can just flip that, and now the z's pointing towards the tool axis. To the spindle nose on the live tooling. So that's all good. Now we can come back and select our faces and pick this conical face, which sets the depth of the hole. And let's do some more peck drilling, so chip breaking on, and we're good to go. Now we've got a 2.7mm diameter hole here, a 3mm hole there, and another 2.7mm here, but that's going to, so we're going to have to have two different 2.7mm drill bits. So let's just do these two axial holes first. So drilling, tool, we'll pick 2.7, so there's 2.7mm drills, so I'll leave 41 for the radial drilling. So we'll select tool number 4 here, and pick this 2.7mm hole. And I happen to know that I actually want it to come past this slightly here just to get that extra bit of depth. So on the heights tab we can turn on drill tip through bottom, and you'll see the green toolpath increase in length there slightly. So now the tip's going right to the bottom of that hole. And on the drilling here we're going to go with chip breaking partial retract again. So I accept that. This time we're going to do the 3mm hole. So we can duplicate that just to keep all the same settings, then edit it. I'm going to change over for the 3mm drill. We need to clear out this selection and select this face here instead. Drill through bottom's already set, and so is chip breaking, so we're good to go there now. Right, now we need to do the pilot hole through here to drill all the way to the bottom of here, then open up the hole and do the tapping. So again, for the drilling, this time we're going to use tool 41. Again, I can't select any of these faces because I need to turn on tool orientation, so I'll select this cylindrical face and flip the z-axis again. Come back here and select my whole face. Now see what's happening here is that the tool is actually rapiding down straight into this hole, and there's still material there, so that's no good. It's going to crash and break the drill bit, so I need to make sure it starts feeding in from higher up. There's a number of different ways I could do that. I could select this face and so on and so forth, but instead I can just use auto merge hole segments, and it's going to look for all of the other cylindrical and conical faces above that and automatically set the height of the hole from there instead. So now we're rapiding down to here and then feeding in, starting into peck from there down. So we'll make sure we set that to chip breaking partial retract. Let's do the same thing again on the heights tab and drill tip through bottom just to make sure we get the full depth. And that's the pilot hole done. One more drilling operation. I'm going to choose a different tool this time. We've got a 6.9mm drill to clear out the material that's needed for the tap. Turn on tool orientation again. I could have, if I wanted to, duplicated the previous operation and just edited everything else, but I'm good with that. At the moment the drill tips only come into this face, so I want it to get all the way down into this conical face here. So again, we need to turn on drill tip through bottom and chip breaking partial retract. Right, so this is Let's have a look, see what type of thread it is. Edit this. Alright, so it's 10.9 mils deep, which is handy to know how deep to go with the thread. And the specification, so we've got 5/16 24 threads per inch UNF thread. Okay, so let's go find a tap that suits that. It's right-handed as well. So switching back to the cam environment, I'm going to use the drilling operation again, and you'll notice here it's still set to drilling rapid out, but if we come in here and change from a drill bit to a 5/16 24 UNF tap, then when we switch back to the cycle, it's automatically changed to the rigid tapping option. So what do we want to thread? Well, I can't select it until I've done the tool orientation. So flip that, come back and select this face here. And the heights have been defined top and bottom by the selections I've made. Well, in this case, I actually want to change that. So the top height I can set to model top, right? And then the bottom height I can set from top height. So they're exactly the same height at the moment, and I know that the thread goes down 10.9 mils, so I go minus 10.9, and now that's going to set my set the depth of my thread, and I can go drill tip through bottom here as well, so that I get a completely finished thread to that depth, and accept that. So now I've got my tapping inside here, and I've finished that hole off. Right, so let's tackle this. It's a 1/2 inch MPT thread. So we can, even though it's a tapered face, we can still use the threading turning toolpath. Select the appropriate insert. So this is to match the 5/16 pitch, or the 1/2 inch MPT thread profile requirements. So we'll select that, switch to the geometry and pick the tapered face. Alright, so we can see here that I'm actually cutting back too far, and I'm starting probably too far forwards as well. So we'll reduce that down to 5 mils so that it starts cutting from, it's going to come down and start sinking from here and start turning the thread. And the backside offset, let's see what we got. What do I reckon we need? Probably minus 1.75. It's going to be just enough to bring it up to here and then start fading out. So it's retracting out to here for every pass, so we can actually decrease that if we want, but we'll leave it there for now. Thread pitch should be the same as the inserts thread pitch, so tool thread pitch, so that's good. It's going to do it in 5 passes, and the finished thread depth is going to be 1 mil, so let's go 1.8. And we're going to fade the thread end out, and that's fine. So there we go. So that's the threading. Right, so we haven't done any simulation for a while, so I'm just going to save this, switch back to the model, and I'm going to turn off. I just right click and press V there to toggle the visibility. Turn off the visibility of the model so that I can see the glory of the thread simulating. Alright, so I don't want to see the toolpaths here, but I do want to see all the stock. Just roughing it out, profiling, done all the drilling. And there's our thread. Let's finish this off. So the next step now is to part this off. So we use the let's go back and turn on that model again, shall we? Use the part operation tool, and we want to select turning grooving tool that's long enough to do the parting. That's it. So let's come to the center, started out here, parted it off all along this spun profile right to the center. So that's ideal. But what we can also do is, if we edit that, we can actually tell it to use the part catcher to drop the part off into the catcher if we're going to do it that way, or we can transfer the stock and switch it over to the sub spindle. We can also use pecking if we want, and then a reduced feed rate once it gets to within say 5 millimeters of the center before it finally parts off. Just to show you what we do quickly to finish it off on the other side, whether we're doing it in the mill or in the sub spindle, 2D contour, we'll select that spot drill again, or chamfer mill, doesn't matter which one we use, get the same result. But the tool's pointing the wrong way, so we just need to turn on tool orientation again and pick this face, and it's just flip the Z-axis around, come back to our contour, pick that edge, okay, and then on the passes tab we want to set our tip offset to 4 mils again, and that's it. So there we have it. So I hope I've taught you something today, a few tips and tricks in there, and also shown that the mill turn side of Inventor HSM is very capable when it comes to these types of components. Thanks for tuning in. If you like the channel, please subscribe, and if you like the video, give it a like. Thanks again, guys. Cheers. Bye.